All right, good afternoon, everyone. My name is Stephanie Moran. I am the Senior Vice President of Innovation for GoTopeka and Link Innovation Labs. So welcome to Link, if this is your first time here. We just opened this facility about 2.5 months ago, February 9th. So it's a relatively new facility. The purpose really here was being able to drive innovation in Topeka. We have our partners, our plug and play partners here who are tenants in the building, as well as our small business development center team. Really, what we're trying to do is create that ecosystem of innovation and entrepreneurship in Topeka. So that one place where people can come, get their ideas out there, we help them grow, help them move those things along. One of the biggest things for this facility is the wet lab space. So there's a shortage of wet lab space available throughout the state and certainly here in Topeka for startups to really be able to work on those technologies in the biosciences industry specifically. And so we have 8 wet lab spaces here in this building. We'll be giving some tours after the event is over. So if anybody's interested in seeing those spaces, we'd love to give you a tour and show you around the space. So I won't take too much more time here at the beginning, but glad to have you all here. I am going to bring Brandon Hutton to the stage from Department of Commerce. Oh, sorry. I'm supposed to tell about the Wi-Fi. Forgot about that. So if you go to Link Lab Guest on your Wi-Fi, and then the password is GTP Lab 2025, and these are scattered around the room. So if you need those, let us know. Restrooms are out down by the elevators and either left or right for men's or women's. So here we go.
Good afternoon, everybody. Thank you, Stephanie. My name is Brandon Hutton. I'm the Director of Innovation Development and Programming at the Kansas Department of Commerce. That means that I provide support to our innovation ecosystem. I develop grant programs and hope to ensure that the money that we get, the very small amount of money that we get from our legislative groups, gets put out in the right way and to the right communities and folks as possible. Today, I was asked to come out and talk about AI in manufacturing. I've been doing a lot of work in the AI space for the past few years, specific to workforce development and education and implementation. And so it's exciting to talk about AI in manufacturing today. I've had multiple conversations about AI in this space. I'm going to be presenting on Friday about AI in workforce, and all of it comes kind of full circle because you can't talk about workforce development or manufacturing and AI in Kansas because Kansas is manufacturing. That's what we are. We are so heavy ingrained with making things here in Kansas that this AI revolution that's here and that's going to continue to evolve is going to really disrupt and change things. And if we aren't having these conversations, engaging with the communities, talking with our elected officials to make sure that they understand what this is, we're going to get left behind. We're already probably 3 years behind, but that's not a bad thing in a space where it's continually evolving and shifting and adapting. One of my favorite things to do, I should have made a PowerPoint because I like to show the evolution of AI articles throughout the years, because it's all started off kind of like, oh, look at this cool, fun stuff. And now it's wild, doom and gloom, and just it's all over the place. So welcome today. Let's talk about AI in manufacturing and just kind of dive into things. I'm really glad that Link and GoTopeka and Plug and Play are kind of coming together and really pulling folks together, because these are happening in silos across the state and not as often as they need to. And so the more that we're able to get together and talk and communicate and hear about what you're all experiencing is really going to help influence how we move forward with commerce programs, with other state programs, and our legislative groups. So you're here to talk about AI, specifically the revolution that's happened with generative AI and LLMs and all that, and how that has evolved and becomes more of a tool in the workplace. Manufacturing is really an interesting space because of the multiple factors that AI is impacting in when it comes to data collection, to digital twinning, to robotics. Not a lot of sectors have the entire comprehensive AI, I would say, like landscape that manufacturing does. And so we get to kind of go on this journey together. We get to figure out how it is being utilized. We get to test and make mistakes and have all that fun. Like I said, Kansas is a manufacturing state. We build things here. There are manufacturers that have been around for many decades that are still using tools from decades ago. And then we have places like the Smart Factory down in Wichita that show you what it looks like to have an Industry 4.0 space. So there's a lot of diversity in Kansas when it comes to the manufacturing capabilities that we have. And AI is going to increase that diversity and ideally build upon the success that we've had over the past, 60, 70 years. The one thing that I really wanted to kind of talk about today, I guess it would be the three things. I want to talk about AI implementation, I want to talk about digital twins and robotics, and those three specific pieces. And why I want to highlight those three are really those are the things that I've noticed have been trending a lot that are really making some waves in this space and hopefully kind of align with some of the businesses that are here that you're going to learn about and a lot of the emphasis that the other places in Kansas are kind of focusing on. So AI implementation across the board right now, it's spotty. It's people are trying stuff out. We are, at a state level, not doing a lot with AI. We've started to have the conversations more, which is fantastic. You go to industry, and I don't think there's a single industry that's really thriving with AI right now. And so we're still in those very early days of a tool that a disruptive, technology, a tool that we don't know what it's going to end up looking like. We're seeing layoffs now, which was, the big concern when this tool kind of got introduced, that this was going to start taking people's jobs. And we're seeing that. We're also seeing counter arguments about how efficiency is not going up with introduction to AI and all this. So it is a wild time. So you being here to learn more is great. We need to really just keep going down this path. Implementation, though, it's a tricky thing to do because it's not historically, I think, as easy as it used to be when you would implement a new tool in a space. If you have a manufacturing facility and you implement a new machine, you get some training done, and it's fairly straightforward. Right now, with artificial intelligence, if you haven't ingrained it into your systems yet, we kind of went through this exercise as a state agency. Is we had to go back and look at our data infrastructure, our data systems, and start from square one, so that we can build into a strong AI network or a strong data network, so that when we do implement an AI system, it's high quality. And so when you look at that level of infrastructure that is required for implementation, I think it turns a lot of people off to it, and it makes manufacturers kind of struggle and push back because that's a really big shift. That's not just adding a new forklift. That's more efficient. That's completely changing your systems, your culture, all of it. And if that's not done right, a business is going to struggle. So implementation, it's a big piece. There are businesses that you get to hear about today that I think are going to help support that implementation piece. So I'm glad that they're going to be here for you to talk to them. So make sure you reach out. Digital twins. Are you all familiar with what a digital twin is? I want to make sure I'm talking to, am I talking to the choir, or are you all kind of new in this space? So if you're familiar with digital twins, just raise your hand just so I can kind of get a vibe. Yes. Okay, good. So digital twins, it's effectively taking a physical asset and digitizing it, putting it into an application or a computer software so that you can kind of play with it effectively. We've seen this a lot down in Wichita with NIAR, how they're able to kind of reverse engineer the planes that they have come in and all the aerospace stuff. It's really the sci-fi things that you get to see. I always think about watching like Iron Man when he is building his suit and he's utilizing technology and interacting it in real time and building those things online and running through scenarios and then getting the data and making something. Digital twins have a very, very important role and have gotten so much momentum with how AI has evolved when it comes to running scenarios and simulations. I was very lucky to go to the NVIDIA GTC conference a couple years ago when they first kind of made some of these big announcements, and one of the things that caught my attention was their Omniverse program or platform, which was digital twinning, and they were using it scientifically with some use cases about monitoring weather patterns in specific regions, and then taking data that they've collected over many years and tracking the level of destruction that some of these wind, some of the tsunamis, some of these kind of weather disasters would cause. And they're hoping to use that as a way to, kind of prevent or at least prepare communities that might be in some of these high destructive areas about, the funding that they might need to continue moving forward. And that just got me thinking about, well, what about like uses in biomedical cases where, you want to run scenarios, and if you can run thousands and thousands of scenarios on a digital twin that is effectively taking this physical asset and building it digitally, are there ways we can speed up R&D processes? Are we able to, upload an entire, factory workspace and make it more efficient? And the answer is yes. That's one of the big use cases that they're doing with digital twins right now. And there's some places here in Kansas that can support you. TDI has got the whole shoulder-mounted camera. They can walk through your entire space and take they can record everything and put it online, and you're able to then kind of change things around and just play around with things. And that's what I like, is that these tools are allowing folks to play around in kind of these safer spaces, that they're not having to then move everything around, and it's more efficient. It's making things a lot faster. And when we start to play around and explore and experiment, that's really where the innovation pieces start to come out. So digital twins is the second technology I really wanted to make sure you're aware of, and that if you're not familiar with it, you should definitely look into it. And then the third one, robotics. I don't think you can have a conversation on AI right now if you're not talking about robotics, especially with a lot of the new tools and new technologies coming out of China. And we've got major robotics companies here in the States. We're seeing more humanoid robotics become commercialized. We're seeing their movement functions and their interactions with humans become a lot less, rigid and robot-y, and a lot more lifelike. And this is another technology that, 60 years ago when the first robot was implemented in manufacturing, we saw what it did. It was able to do a very repetitive process. It sped things up, and it led to a complete industrial revolution. AI is pointing in the same direction. It's creating another industrial revolution, and I believe that the implementation of humanoid robotics is going to really push that even further. They're just recently they had one that was able to run a half marathon, and that's not too crazy to think about for a robot. But if you look at the types of energy that is required to do that for that type of robot in a humanoid like a skeletal system, it's wonderful. It's crazy. What other implementations and implications does that going to do for prosthetics and all these other things for manufacturing workers that need additional support lifting? But also, we look at the human piece of manufacturing and where that human is still necessary. And a lot of it is in some of that manual, maybe in some of that precision piece. And the way the robotics are going is in that space. It is not attacking it, but is being supported to, a lot of funding is going towards figuring out if robots can do that precision piece. And there's some really interesting things coming out. So manufacturing and AI are very, very important together. There is going to continue to be revolutions and innovations as we move forward, as these AI tools become stronger, as our robotics pieces become stronger, as our digital twinning becomes stronger. And we as a state want to make sure that we remain competitive. And so us engaging with you, you engaging with us is so key right now, because we can't push anything out our doors unless we get told from our legislators. And if you're not talking to your legislators, then where are they getting the information from? If it's from the articles that I'm seeing online, it's all doom and gloom, and they're going to stay away from this stuff, and that's going to put us behind. So I'm glad you're all here. I appreciate you all taking time to learn more about some of this stuff. You're going to learn about some of the trends later on today. You're going to hear from businesses that are providing services in the AI space, and it's just a teaser of really what's all out there. So again, my name is Brandon Hutton. I'm with the Department of Commerce. I've got information with me that I want to make sure I get out to the businesses that are here. But if you have any questions, you want to have more conversations, you want to learn more specifically about what's happening in the state, please reach out to me or Romain in the back, our Chief Innovation Strategy Officer. We are here in this space. We want to make sure that we are kind of navigating it with you, and all the interactions that we have at a state level, I want it to be not only based off of research that I've done, but also raise up your voices too as much as possible. So thank you so much. Lindsay the Great. You had me all confused. Lindsay the Greatest Laban is up next.
Yeah, I should have put the greatest up there too. That's really... Thank you, Brandon. For those of you that don't know me, well, you know me for a little bit from my crazy emails, but I'm Lindsay Laban. I'm the director of Plug and Play here in Topeka. Some of you probably don't even know what Plug and Play is, so raise your hand if you have no idea what Plug and Play is. Yes, this is what I love. Okay, so I'll tell you a little bit about Plug and Play and who we are. So our mission is to drive innovation by connecting corporates, startups, universities, governments, and we do this on a worldwide network. So we believe that it's open innovation. Innovation you have to go outside of your four walls in order to really make it happen. So that it takes everyone at the table. You have to have the startups there. You have to have the VCs. You have to have that culture from the city. You have to have that buy-in, those pilots that are being able to run, the VCs that are able to back it. So it really takes this entire wheel of everyone at the table in order to really drive that innovation. You can't just be done with Stephanie and I in a room trying to support one startup. It's got to take Brandon at the table. It's got to take the universities here piloting. It takes everyone, and it's really hard work, but we've got it kind of down to a science. So we got our start over here on the left, venture capital. Our CEO met a startup out in the Silicon Valley, right outside of Stanford, and they were interested. They're like, "Hey, you've got a rug shop. I need that office space up there." He's like, "Yeah, tell me about your business." He's like, "We don't have any money. I really want to just, try and get some space." He's like, "I'll give you some equity in my startup." He's like, "Tell me a little bit about it." They go on. He's like, "Yeah, you know what? We'll trade some equity for rental space." And he started talking to his golf buddies. He's like, "Hey, have you ever heard of this little startup called Google?" They had no idea who it was. And so he started seeing how the corporate world and his golfing buddies that were huge in the corporate world had no idea of these little startups that are actually changing the world, and he was believing in. And so that's kind of the business model that we had. So we started off as a VC. That's still our heartbeat, is a VC in early stage venture capital. So try not to use as many jargons as I can. Early stage venture capital. We are looking at startups that are 5 years from shelf life. So very, very early stage that need a lot of support and a lot of networking in order to make it. We're trying to bridge that gap, make those connections for them. We are one of the largest VCs in the world. We write 250 checks a year, anywhere from $50,000 to $100,000. So not leading rounds, definitely not the largest checks in the world, but we are writing the most. So these are some of our unicorns: PayPal, Lending Club, Turing, Dropbox, Honey. So very common. We also have lots that you've probably never heard of and probably won't hear of for another 5 years. But a pretty good portfolio behind us. Like I said, Saeed's out on the golf course. He understands that these corporates don't know these startups, and they should. and they want to know these startups. So that's where our corporate innovation platform really started. We work with over 600 of the world's leading brands and help them with their external innovation, help them go outside their walls and filter out some of that noise that, there's lots of startups that would love to work with Walmart. Walmart doesn't have time to vet and meet all of them. They come to us, they say, hey, Lindsay, we really need X, Y, or Z. What startups are in that space? So that's something that all of you in this room, our team is happy to connect you to startups. So if you see the startups today, that'll give you an idea of what kind of startups are in our ecosystem. But if you've got a problem that you're trying to solve or a technology that you really want, come to us and say, hey, what do you have in this space? We're happy to go check our network. Mark, our ventures team back there, who you'll hear from in a little bit, is more than willing to go out and see what we've got that can help connect you. So we really want to be that connective tissue to not only our corporates here, but our corporates that are in our ecosystem, as well as our startups. Same thing, startups, I see a couple startups in the room, always want to be your connective tissue too. Like, even though I'm animal health, we'll get to that in a second, I want to be your connective tissue into the Plug and Play ecosystem. Which kind of brings us to our accelerator program, geared towards the startups. We want to take those early stage startups and make them as investable as possible by connecting them to resources, mentors, programming, really set them off on the right track so that when they do get the chance to meet those corporate partners, they put their best foot forward and they have a chance to really work with them. I talked a little bit about this. We are in 25 different verticals. So today you're hearing AI and advanced manufacturing. We also have supply chain. We've got animal health, ag tech, media and ad, you name it, we've got startups. So each one of these verticals or industries kind of acts as its own ecosystem. You've got corporate partners within that space. You've got startups in that space, universities, governments that are focused on that, regions that are focused on that. So each one of these really acts as its own ecosystem, but we have preview to all of it. So that's what makes Plug and Play a little bit different than some other accelerator programs that might just solely focus on food technology. We have food technology, but we also have ag tech that affects food technology. And we also have packaging that affects the food technology. So these are all of our industries. Most of you would fall into one, if not multiple of those. So happy, again, to connect you if you want to know more about a specific industry or vertical and what we have going on in that space. Happy to connect you there. We are also in 65 locations around the world. That global presence, I talked about that. That's our mission, is to drive innovation on a global landscape. This really means that we help not only startups and corporates, but it acts as a soft landing pad and launch pad. So if a startup comes from, we have one coming in from Japan, and he wants to know how to do business in the US, we have a soft place for him to land. He also has a colleague in Germany. We have an office in Germany, and we can help them really connect those dots. So it acts as a landing pad, but also a launch pad, because they don't, hey, we're exploring business in South Korea. Okay, I can connect you to my office there who knows everyone in South Korea and can get you connected in. So again, it all comes back to that connection, and that's really what makes Plug and Play special. As you can see, there's lots of really great names up there, and then you see Topeka, Kansas. I'm really proud of that. It often sticks out to a lot of people, where it's Shanghai and it's Paris and Topeka. Topeka is often overlooked, and I don't understand why. We were very bullish about getting Plug and Play. We really thought, why not? And I love that about Topeka, is a lot of times it's, well, why wouldn't we? And that's what makes Topeka special. It's the creativity that I think Brandon was talking about, like willing to go beyond just standard, well, we don't have one, so let's go get it. We have 700 employees, again, scattered out throughout the now 70 plus locations. But for Topeka, what does this all mean, right? It's all great, it's all jargon. What does that mean for Topeka? So for Topeka, we launched in 2020. We had the focus of animal health, obviously being in the animal health corridor. We've also expanded into ag. Obviously, that's also a natural fit for us. Both are very small, very niche industries that take a long time. There's a lot of regulatory it's hard to get farmers to do anything besides just farm, right? So launched in 2020, we've had over 100 startups come through our program, which means 100 startups now know of Topeka, Kansas, because a lot of times I ask them, like I asked you guys, do you know of Plug and Play? I asked them, how many of you knew about Topeka, Kansas before this? And I've had one raise their hand before, and it's because they were from Kansas City. So now 100 startups have known, been, experienced our region. When we have them come in, we showcase the entire region. We showcase our universities. We have our government talk to them. We get to see the local Kansas City Animal Health Corridor and everything that we have to offer here. We've made 300 introductions. That is to our corporate partners, to some venture people, to local economic development places. Of those 300 introductions, we had 80 NDAs in place, which means most of the introductions are going somewhere, right? They aren't just a dead end. They're having those additional conversations. They're bringing their additional teammates in to figure out what they're doing, how they're going to work with them. And of those NDAs, 47 of them have gone to pilot. Again, pilots can last depending on what it is. It could be a 3-month pilot or it could be a 3-year pilot. And they're all kind of along that. But again, it's showcasing that the right startup is meeting the right corporate and actually moving that innovation along. Now, we still might not see it. They might not move here, and it might not come up to fruition for 5 years, but it's happening in the background. And I think that's really, really important to kind of understand and know. Okay, so now you know a little bit about Plug and Play. We're gonna showcase what Plug and Play is here in a little bit. But before we get started, I wanted to bring up Jason Andrews with Gemtech to kind of talk through a case study and how he's implementing AI in manufacturing and give us a really good look about what this is and what it could really look like here in the Midwest. Then we'll have some of our startups. They're going to be some of our portfolio companies log on. They'll showcase their technologies, and then we'll hear from Mark. So this is very typical of what a Plug and Play ecosystem looks like, right? You've got some industry expertise showcasing what's worked well. You've got new startups that are giving you brand new ideas, and you'll hear some new trends from everyone. And you've got a room full of people, the entire ecosystem right here. So thank you all for being here. We appreciate it. And Jason, floor is yours. Yeah, of course.
All right. I've got some notes here, so I'm going to set those down first. So I can assure you all that I was not selected for my expertise, as you'll know, but hopefully it will be an opportunity for us to learn from each other. So I want to thank Go Topeka, this great space at Link Labs, and then all of you for coming here to have this discussion, because you've got other things to do. And if one of the things that we can all tend to do a lot of is working in the business and not zooming out and working on the business. And so the fact that you're here today is a testament. So I want to say thank you for that. So I want to give you a little background. I'm going to get that picture of me away quickly. And so some of this is going to be AI, and mostly it's going to be how we're thinking about AI as Gemtech. So who we are, what we are, and I think that'll provide a little bit of context. So we do plastic injection molding. We are an old school manufacturer. We do a little bit of thermoforming, and we are right at about, this year, we'll be at about $10 million in revenue. So we are 3 shifts a day, 5 days a week. We've got about 55 people, okay? Not very long ago, we had no automation at all. So we're thinking about AI through the lens of efficiency. So one of the things that we try to do as a business is chase better. We want to be better. Well, what does better look like? And what are the tools that can help us deliver better? And we think AI is one of those tools. It maybe isn't the only one of those tools, but we're trying to get better, and better defined as, easier, safer, cheaper, any of those things that can help define what better looks like, right? So that's our building, brand new building. So I'll give you 30 seconds on the history of Gymtech. So started as a mold maker, so tool maker. That's rarely done in the United States anymore. That has almost all been offshored. The design of those is still done here, but almost all the tooling is made overseas. Moved into injection molding, a company called Trend Plastics, started in KCK, moved to Olathe. The reason we're called Gymtech, it was purchased by a guy who owned a playing card company. So if you have playing cards, there's Bicycle, there's Hoyle, and there's Jamaico. Those are the three biggest playing card companies. Jamaico's a distant third. You're probably very familiar with Bicycle and Hoyle. But anyway, so that's why it's Gymtech. He bought Trend Plastics to make poker chips and pie gow tiles. So that was the reason for the business. Then somebody wanted his playing card company, which was based in Blue Springs. So he sold that, moved to Vail, kept the business for 12 years. So he owned it remotely for 12 years. Maybe 11,000 square feet in Olathe. Most of our customers, long-standing customers. So in the injection molding space, in the custom injection molding space, the customer owns the mold, and then we run the parts for them, right? So they have the part, they spec it out. This is the material. Here are the 4 or 5 critical dimensions that we want you to measure. And, we'll order them from you. And in 30 days, you have them ready for us on your dock. So that's what we do. So anyway, fast forward, COVID is really good for our specific business. I wasn't even in the business at this point, but it was really good for Gymtech. Can't say everything for plastic injection molding or manufacturing, but for Gymtech specifically, it was really good. So previous owner Dan has this idea. I'm going to get some incentives from Spring Hill. I'm going to build a building that's 4 times the size of the building we have now. This is going to be great. It's going to be my swan song as an owner. Well, the building costs about 30% more, takes about 30% longer than he thought. And at post-COVID, the business starts to go like this. So enter us, right? Or me, I'll say mostly. Oh, anyway, so before we get to that, most of our customers are local regional customers. So we are not focused on automotive. We're not focused on, so we don't have OEM relationships. So most of the value we provide is we make little things that go on other people's big thing. And the part that they value from us is that we're close. Some of it is close so we can meet. Some of it's close so they don't have to pay to ship it across the country, right? So there's lots of value to being close. And so we've got, long relationships with lots of people that are local and regional, but it is not specific to any industry. And so our value is really around that proximity piece. Although that's where the decision's made, we do ship all over the world. So they may ship to different places and we help to facilitate all of that. But generally for 70% of our customers, the decision is made within a tank of gas of our plant. Okay, so kind of pick back up with that story. So for me, my life has been building and scaling sales teams in medical device. So I did a lot of years doing that. If you do that based in Kansas City, you travel a lot. So I did that. And then I had younger kids and I wasn't that interested in traveling a lot anymore. And so in 2015, I engaged a company to help me find a business to buy. So bought a healthcare services company in 2016. So something I was somewhat familiar with. And for that, so my entrepreneur gene is not in thinking of something that doesn't exist. So that kind of will play back into this AI, right? So I think in terms of improvement. I think in terms of incremental. So my head can wrap around seeing something and growing it or improving it or making it more efficient. I can think along those terms. Something that doesn't exist today and breathing that into existence is not where I am, right? So that's the lens that my presentation, that's how I'm looking through these things. And so I just want to provide that. So anyway, sold that business in 2022 to a strategic, didn't do anything for 18 months. I was in this business owner group. A guy says, hey, listen, we're going to buy this manufacturing company and we would like for you to be a part of it. You can be as big a part of it as you want to be and we want you to run it. Okay. Well, in my searches, With my first purchase, it was a full SBA, every dollar I owned, lots of personal guaranteed loans. I was not that interested in doing that again. And so this sort of fit the bill. So the good news is we paid cash for it. The bad news is it was losing $10,000 a week. So, you kind of get what you pay for. So, but we knew that. It had potential, as they say. And so what did that potential look like? I was dumb enough to think that I could realize that potential, not knowing anything about manufacturing, just because I kind of knew small business and I kind of understood things and I could look at it from an outsider's perspective. Some of that has worked out, right? And so we already knew people that knew how to make stuff. I remember the old owner was in Colorado, so he wasn't there every day helping the people make things. So the fact that they have a new owner that doesn't know how to make things, that part didn't change. So I was going to be there every day. I was going to ask different questions and all those sorts of things. So that's been the real opportunity, is how do we get better? Because the first thing we had to do, because we were small and in manufacturing, it's a high fixed cost structure. So it's a lot like a hospital. Like before you have one patient walk into the hospital, it's really expensive, right? Or whatever you want. So it's a high fixed cost structure. So number one, before you can worry about getting a lot better, you got to get bigger. You have to be large enough to make it make sense, and then you can start working on efficiencies. But if you start working on efficiencies when you're too small, it doesn't really matter, right? At least that's been my experience. So what were the real opportunities? So one was fill up this new building that kind of had tumbleweed rolling through it because it was so empty. So we needed to add business, first of all, and now we've done that. So we've maybe doubled in the last 2.5 years. That's been great. And so over the last 12 months, we've been working a lot on what efficiency looks like. So how are we going to do better? What does better look like in all sorts of ways, big and small? So this is our plant. And I'll say this was our plant. So when we bought this plant, we had all these machines. These are plastic injection molding machines, and they were facing this direction, kind of long-wise. And so when you're going from an 11,000 square foot building to a 40,000 square foot building and you haven't really planned for the move and everything goes crazy, you just put them anywhere you want because there's so much room, it doesn't matter. Well, when you get bigger, it does matter, right? And so in our first year, we spent 6 figures moving the machines. And what did moving the machines look like? Well, on our smaller machines, which we put on this side of this trench, right, so where water and power run through. Our bigger machines are all powered on this back wall. We moved our smaller machines to this side and we put them in pod systems. So we created little work pods. And those work pods saved a few thousand steps a shift. And 3 shifts, 5 days a week, were hundreds and hundreds of miles of saved steps. Well, those hundreds of miles of saved steps is hundreds of hours of saved labor and on and on and on, right? So that's, when we're thinking about efficiency, did AI help lay out, give us some layout ideas? Yes. So it's like, it's not just the size of the machine, but how far away do things need to be? What do the ancillary equipments, the dryers, the blenders, the thermolators, what do we need power-wise? How does all that look like? And laying all those things out, that was one of the things, right? So one-time project thing, but important and permanent, right? So we get that set up. We see those savings go on and on. So we talk about manufacturing generally, how much it's changing. Well, guess what? Everything's changing, right? It is like, that's not new. So 20 years ago, I'm over 50, so this is applicable for those of you that are, but your gastroenterologist was doing how many colonoscopies a day? 8. How many is he doing now? 20, right? Now, he didn't go from 8 to 20. He went from 8 to 9 so how do you get there, right? Well, what does that look like? Well, most of it are small incremental gains. And it's not just one person, right? It's like, what's the ancillary staff doing differently? How's the technology that they're using differently? How's the scheduling different? How are all the things that lead up to it different? So that one person who's doing the scan is more efficient. Now they're overlaying AI into reading the scans so that polyps that are sometimes naked or can't be seen by the naked eye are detected earlier, right? So there's even ways to make it even better, not necessarily faster, but better, more valuable, right? So when I think about that from a manufacturing environment, I think I have 17 machines. So I have 17 gastroenterologists, and the only people that make money in our plant are those 17 machines when they're running. And so them running and them running efficiently is what all the rest of us have to do. Easy thing to say, tough thing to do, right? So the visibility gap around mid-sized shops. So it is easy to hear about and see what Panasonic may be doing in their however many billion-dollar plant. And some of it is inspiring and it's almost immediately crushing because it's like, all that takes resources I don't have, so that's great, but, right? That's the way I feel, and maybe that's just me, cynical me, but that's the reality. It's like, some of these things are great, but it takes time and it takes resources, and I've got very limited amounts of both of those things. So what can I actually do in my size range that can drive some of these improvements? So what I would say, and I had this conversation earlier, is in so many of these things around AI, think smaller, think single project, think one small thing that it's like, that's repetitive, that maybe it can automate, right? Go low stakes early. Don't think, how can this change everything? Right? Because the reality of it is, and I would also say, and I don't want to disagree with Brandon, but I don't think we're that far behind. I think there's a lot of people who have the people that have started doing some things on AI, a whole bunch of them are disillusioned. So how many people have started things in the small and mid-sized company, implemented them, and are seeing positive returns? That's a small number. Not saying it's zero, but it is a small number. So we are still on the forefront of figuring out how this can drive value. The tricky part is it is different for everybody, right? So it's like, while the things may rhyme, it's going to be very specific to what it is for you. The key is, how do I make, just trying to make things better, and how do I get better information and make better informed decisions? Can't make informed decisions without information. So how can I get that information? Again, this is no longer optional. It's becoming a part of what it is that who and what we do. So what we're working on. So when I talk about efficiency and I think about it through that lens, we have our operational efficiency. So what's the efficiency of the people that support our operation? Okay. So our operations team, how can we use it to better understand our costing? How are we utilizing, we're using it, and I've got a screenshot of it, but Base 44, which has a Claude background, to better plan out our scheduling, right? So it's like, if our 17 machines are the most critical pieces of that, right? So what we need them running. Well, I had this conversation earlier. When a machine is running, an injection molding machine is running, it wants to stay running. Our plant, we're not open 24 hours a day, 5 days a week because people love working the third shift. It's because getting the machine started, doing all that stuff is a big part, and then it wants to run for 20,000 parts, 100, that wants to run all week. And shutting it down on Saturday morning is a sad day because even though it ran great last week, next Monday is a whole new day. And it might be easy and it might not be easy. So figuring out ways that we can automate some of our processes and operations. So we're using that to get better visibility, understand where our downtimes are, because it's like previously what we were doing is like, oh, we're going to have 6 jobs that are going to finish today. Well, when are they going to finish? Because we have one person that changes molds or a team of 2 people that change molds, and they can't change them all at the same time. So how are we mapping that out so that it's a little bit more like a NASCAR pit stop, so that this thing is happening and they're here and they do all the stuff here, and now this one's running and they go to this one and everybody's got clarity, right? And so this Base 44 gives us that visibility, allows us to change it and do all those different things. And then a lot of our efficiency has been production floor automation. So we've got press side automation, we've got co-robots. I've got a couple of videos if they run, both of those things, it is not super high tech, but it is super valuable to us, because when you take something on a plant that runs 120 hours a week, 50 weeks a year, 6,000 hours, and you take something from a 100% operator job to a 20 or 25% operator job, it's thousands of hours of labor savings. And the one thing that we're seeing is labor it's difficult to get, it's costly to train, it's costly to retain. And then the other piece of what we're doing is automating redundant tasks. And so for our operators, we want them to do the things that are highest and best use, just like we do with everybody in our plant. And so taking some of the most redundant tasks and automating those is both a dollar savings and really helps with our people. So this is that base 44. And so it breaks down every job on every machine and really helps us space that out visually so that we understand uptime. We understand when they're down, how many machines are down. It helps so when a machine's running and then a job is over, the mold has to be changed, the setup has to be different, it's new material, that material might need to be mixed, that material might need to be dried. There's lots of things that go into the next job. And so there are different tabs, whether you're the material handler, whether you're the person setting the molds. And this is this was a very inexpensive subscription basis that we just load our information in and it spits this back out. So I was mentioning this earlier. One of the things that is a little terrifying to us as it relates to AI is totally getting rid of anything legacy. So today we still keep the information in our legacy systems. Even though we may use this, we've kind of got our old scheduling system. And so the data is still there if we need it, but we're using this one almost exclusively, if that makes sense. So if we load everything in there and then the data goes away and we don't have a place for it, we're just a little terrified of that. Maybe that shouldn't be something we're terrified of, but we are. I don't know if this works. Oh yeah, it does. So this is what press side automation looks like. This is my phone camera, so it's not a very good view. But what that does is it takes these two things, which are airline trays. So they're the trays you see at American Airlines. And what it does is so when you talk, it just picks those up, drops those down, indexes those. So those go in boxes of 50, 2 stacks of 25. It does all that and then moves those. And so instead of having a person there, this does that. And it checks all those boxes of the time is exactly right on the system. So it's more efficient. It's safer, it's easier. I mean, all of the value boxes it checks. And so then the nice part is every time we put that thing in there, we run 25,000 of them. So it runs for 10 days and then it runs a different kind of tray. And it's fantastic for what that does. So we've got a couple of those running and we've got 2 more that don't run very often. We got to find, some of that is we got to find better jobs for them. And some of it is, doing better with our skill set within our plant to expand that as well. But press side automation, it's not super sexy, but there's real value there. This we're still working on, and Bradley knows this one. Maybe it's there. No. Oh, that's just the thing. Well, anyway, so this is still in the playroom. As you can see, there's a lot of stuff laying around there. But this FANUC robot is basically just so we make a gas can that has a valve that needs an O-ring put on it. So 2,000 hours a year today, I have a person that does this, and it plugs into a little thing, puts the O-ring on it, and goes back into a box, right? And so this FANUC is going to do that role, right? And so we've got 2 of these FANUCs, and so they're cobots. And so instead of being big press side, like we have to have a cage around it because if you mess with the press side robot, it will win. These, if you bump into them, they'll stop, right? So they're meant to work around people and do more fine, small, fine motor types of things, right? But again, when we talk about efficiency and how we can utilize these, that's the stuff that we're working on. So I'll tell a little bit of a story here, but so we have three, and this is a fairly new thing. Last couple of years, we have 3 3D printers, 2 FMD printers, and 1 resin printer. So why? Well, what these allow us to do are partner on newer opportunities, like be of value farther up, right? Farther closer to when things are being thought up, dreamed up. So if somebody says, hey, I'm thinking about this, we can print that out and have a meeting the next day and talk through it, right? What it also allows us to do is, what we found is get engaged sooner on development of different things, because there's a huge difference between making things one time or making 10 of something and making hundreds of thousands of something, right? And so how can we utilize this to, number one, get better there, and number two, we use it a lot internally. Go, no-go gauges, we're using it for a lot of getting better internally. It's probably 90% of what we use it on, really, is for making ourselves better, faster, more efficient in the plant. But we like to be able to engage in opportunities at an earlier stage, and I'll get to that in a second. So this is why regional collaboration matters. So it's things like that. So what I would tell you, and I've said this a bunch of times, so Gemtech's been around 50 years. There are, not even a question, most people who need our services, I say need our services, use people like us that are Kansas City companies use people just like us, have no idea we exist. And it's not like, oh yeah, we knew about Gemtech and we use this other group that's in Lenexa. It's like, no, they're using somebody in Milwaukee because they have no idea, because 30 years ago they used somebody in Milwaukee. They have no idea that it could be done here. They pay the shipping, they do all this stuff. Like, they have no idea we exist. So why regional collaboration matters is, like, where can we be of value to each other in helping? Like a lot of times we can't be helpful, but I might know somebody that can be helpful. I might know somebody that can help solve a problem, whether it's on the manufacturer side or integration side or any number of things where it can be valuable. So, meeting with different groups, different regional groups, helping to think about big problems. When we talk about, when I think about all the problems, like who am I competing against? I feel like I'm competing against who we are today and what we want to be. It's not, oh, this plastic company down the street. Like, not an issue. Lots of business for all of us. Quite frankly, it's not overseas. Overseas can do one thing I can't: lower cost. That's the only thing. And so if you think of everything that you've purchased this week, how many times was the lowest cost the reason? Like, did you go somewhere you did a 49-cent cup of coffee? Terrible cup of coffee was 49 cents. Did anybody do that? Is anybody driving around to try to find, really bad gasoline, even though it's crazy expensive? It's like, oh, I don't really care about if it's any good. I just need it to be really cheap. There are people like that. I'm happy that they're somebody else's customer. I don't want to compete on that level. That doesn't mean we can be inefficient. We've got to be the best version we can be for our own profitability, to be able to hire and retain the best talent, and to be able to be competitive for our customers. But we do not compete solely on price. And most people don't. They're scared, that becomes a big thing. We don't compete against China. We just don't. We compete against ourselves mostly, and how much better we need to be and how much faster we need to get there. So I want to give you a Love Life Sciences example. Bradley Hopper and his partner, Nick Love, are on a journey and have invented a product and have a number of products on the way. But I'll say 3.5 years ago, they came to Gemtech. I have no idea still to this day how they found us, but it was not easy. It's probably still not super easy to find us, but it was damn near impossible then. So he finds us, he reaches out and says, hey, listen, we've got this thing. And here was our response. Yeah, that's too small for us, but maybe there's some 3D printing capabilities at K-State and they can help you out. Good luck. And then our follow-up was nothing. Right? It's amazing how this business hasn't grown. So my first week, second week after the purchase, serendipitously, Bradley reaches back out and says, hey, listen, here's what's happened. His journey, he goes to K-State. They actually help him out. Then they go somewhere in Iowa, get some aluminum molds made, and they have struggled and struggled and struggled because they keep getting pointed in the wrong direction and they're not getting help. Because guess what? They're not really good at making things out of plastic, right? Not their core competency. They're trying to figure it out and no one's helping. So reaches back out again. And I'm like, okay, we're going to do this a little differently. And we have. And so we have really partnered together to try to help commercialize this product, right? And so what does that mean? We're not smart enough to think of anything, but we are smart enough to know, hey, if the parting line's here, or if we do this and we've got to eject the part this way, it's going to make it a lot easier to make that part, or it's going to make it a little less expensive to make that part, or here's some ways we need to think about assembling that part. And then here's what we should think about doing it today to pay for tomorrow as you grow, right? We're pretty good at thinking through those things and having those ideas. And so really that's our value. And so before we'd be like, that's not something that we can do because not our thing, to how can we help you get there so that we can go on a journey together, right? Different way to look at it, more fun. I mean, that's what we want to be a part of, because as we continue to grow, we're not going to have 1 million customers. It's not what we do. Like, we run lots of parts for a few different people that we have deep relationships with, right? That's our business. It might not be yours, but that's ours. And so when you talk about what differentiates you and how can you be valuable, how can you overlay these things to remove repetitive processes, right? And put your best people in the best places, right? Wherever that is. For us, it's like we've got people that need to be customer facing. We've got people that need to be in front of a machine, right? There's 3 degree programs in the United States to do plastics processing. One of them is Pitt State, Kansas. So we have a supremely talented young plastics engineer. And every time I see him in front of his computer, I wince, right? Like, he doesn't want to be in front of his computer, and I don't want him in front of his computer. So I don't need him filling out forms that he doesn't want to fill out. I need him in front of a machine doing things nobody else can do in our organization, and teaching other people some of his skills and trying to make that a little better, right? So how do you use some of these tools to get that done? It's one of the things we're thinking through. So you guys know all this. And so I'm not going to sell you on this, and I don't know that we need to sell anybody on this. From a Kansas standpoint, we're in great shape, right? We've got a willing, skilled workforce that is at least there to be skilled, right? Like, we actually have high schools that still have shops. There are places that don't, right? Kids that still want to make things, kids that still see other people in their lives that make things for a living and actually make a living doing it, right? So we're in good place in Kansas. We've got a good workforce. We are located in a good place, and people are pretty willing to help each other out, right? And the cost of living is amenable to manufacturing. And quite frankly, you can get some land. Ours is too damn expensive and the taxes are too high, but probably not compared to some other places. So there isn't anything, I wouldn't tell you like, yes, a lot of these things are absolutely not perfect, but relative to other places, they're really darn good. So none of this can be an excuse for not succeeding here, in my opinion. AI gave me all this, all of it. I don't even know if any of it's true. That's the thing. I didn't even validate it. So it all looked good. So I went with it. But things like, yes, there's some legacy things, but the animal health, I mean, that has been dug out of the dirt over the last 10 or 12 years. It didn't exist. And it's like, oh, we're going to plant a flag. We're going to attract companies in this little corridor. We're making it up. We're calling it the animal health corridor. And guess what? They breathed it into life. And there's innovation coming here and more to come, and it's building momentum. It's that sort of thing that can happen in other places, can happen with collaboration. There's no special sauce other than a lot of hard work, a lot of communication, a lot of collaboration. So what's working, what's not, what I've found is there are a lot of resources. Plugging in with those resources, there are probably more. These are 4 that I've personally interacted with on the manufacturing side. So where can you get out there and intersect with others that are doing hard things? And I would tell you, making things is the hardest thing to do. It's noble work. But I've been in a lot of other things, and there's nothing that is quite as challenging or gratifying as making things. So people, and it's a small community, and when you run into other people that are doing that, they support each other. So I know all of you are that way, and so go meet other people that are that way, and good things come back. Economic development, prioritizing manufacturing. This one's a big one. So, you know, talking to legislators, getting that word out there. The tax incentives for a data center are enormous. The economic impact of a data center is not enormous, right? It sounds really super cool, but they don't employ anybody. Server farms don't employ very many people. Like the job creating industries should have a preference, right? And it's not super sexy, and we don't have huge lobbying groups and that sort of thing, but that is the message that needs to get out there. The incentives need to be there because people are going to follow the incentives. You know, whether it's us, whether it's our customers, we need certainty because the payoff on these investments are not fast. So when people are talking about building tools or they're talking about investing in, you know, AI things, investing in automation things, we try to track an ROI on all of these things. We would love for all of them to be under 12 months. They aren't. And a lot of our customers are looking at 5-year ROIs. Well, in order to do a 5-year ROI, you have to have a lot of certainty to make that decision. And so where we can help bridge that through incentives, we want to try to encourage our people to do that around job creating industries. And then, you know, harnessing the new innovations. I mean, again, I'll wrap up to say, you know, I'm not going to tell you that Claude is better than ChatGPT or any of those things. What I would say is these are tools in your toolbox. And where we have seen success is in finding a problem that is a repetitive problem and attacking that one small thing, right? And then measuring it, right? So we're not trying to revamp our entire plant yet. We're trying to get a little better on one thing and a little better at tracking our AR and then a little better at tracking our raw materials and our raw material turns, right? And then, you know, starting with our largest customers and then moving to some of our older stuff and feeding all of our data sheets in is what materials are close to this. You know, all of those sorts of things. It's all the questions that we're asking. The more specific we're getting, we're iterating in those things and we're learning. And as we learn this information, we make more informed decisions. So it is not transformative. It's been incremental. We're dipping our toe in. But we have seen some good results. We expect that it will. Human with technology is always going to beat technology. So we always want another person, we want our people looking at it, we feel like that's our expertise. And that's all I got. What questions do you have? Yes. Yes. Yeah. So it loads. So we just took it. I mean, just reams of electronic data. We just loaded it in there, which basically tells it, you know, what's the cycle time? What is the material part weight? So it's all that stuff that we managed outside of that. And it just chewed it up. I mean, it was easy. Yes. Yep.
We'll do a little technical switcher up here, but I'll give a quick brief. So as Lindsay mentioned, my name is Mark McAllister. I represent the ventures team here at Plug and Play. So I manage most of our relationships with our startups and can contribute to that side of things. So we've got 4 companies that will each be virtually presenting. Each of these 4 companies are 2 things. One, we've invested at some point in the last few years into the company, and then all of them are partners of ours or have collaborated with some of the corporates in our network. So with that, would love to jump to our first presenter, which will be Base2, and I will let Ann run a few things here on logistics.
Just going to point out one thing really quickly before I forget. So that QR code will take you to a form that allows you to connect with any of the people who presented today. And I'll show it again at the end, but if you want to pull it up now so that you have it handy before we switch to the Zoom screen and I hand it over to Kiefer, that would probably be ideal. Again, I will show it at the end, but I wanted to draw your attention to that also.
Yeah, Kiefer, if you can hear us, we're ready for a pitch. Kiefer will be joining us with the Base2 team, as mentioned. Base2 is working on an AI platform for industrial intelligence and digital twins. I'll let Kiefer take it away.
Awesome. Thank you. Testing, just making sure y'all can hear me.
Loud and clear. Go ahead.
Perfect. Perfect. I'll start sharing too. Make sure this comes through properly. Okay, and triple checking, everyone can see my screen? Cool. I will assume so. I'll jump right into it. So hi, folks. My name is Kiefer. I'm the Chief Customer Officer here at Base2, one of the co-founders. I have a 10-minute presentation to kind of walk you through our company and our technology and how it works. Try to get through it as quickly as possible, give you as much interesting information as possible. Starting off with, I think, some of the slides that people care about most is who do you work with? What's your established reputation in the market? We're working with some of the largest pharmaceutical, chemical, cosmetics, human health types of manufacturers, everyone from good old Johnson & Johnson and Takeda and AstraZeneca on the pharmaceutical side of the business, all the way to L'Oreal in Paris in the cosmetics division, as well as several larger specialty chemicals and other types of manufacturers, even in the Japanese and Middle Eastern market. And of course, our investors are highlighted on the right, including lovely Plug and Play, which we always appreciate. Getting into the reason why we exist. I come from a background in pharmaceutical manufacturing. Prior to founding Base2, I was at Johnson & Johnson. And what I saw within a regulated manufacturing environment is that a lot of the existing operations are kind of run on something like a paper or Excel-based system. So if you're a scientist or an engineer, you're trying to improve your process, making a decision in real time is pretty challenging because a lot of the tools that you're using are kind of legacy. I believe that was a word that was used in the previous presentation. Again, I don't hate legacy tools, but oftentimes they can be a little bit restrictive or prohibitive when it comes to actually making real-time decision-making within a plant. So this is why we made Base2. We'd lead manufacturers into the AI era by essentially providing an end-to-end digital twin or simulation platform. The idea is that with our platform, we can connect to an industrial database, like some type of SCADA or Historian, or even like an Excel file, and allow engineers to build data pipelines that clean and pre-process and transform this data, and then funnel this data into physics or data-driven simulations of individual manufacturing processes. So this could be everything from a distillation column to a mixer to some type of specialized kinetic reactor that's a hybrid of a chromatography column or whatever other process you have. The GIFs or animations that I'm showing you on the screen are kind of the 2 core experiences in the platform. On the very left, we kind of have like a workflow builder that allows like an engineer who really knows their processes to build a model, build a simulation of the actual process itself, like a digital twin of that process. And then on the right, we allow these engineers to expose or build apps or applications. And these are basically end user dashboards where, let's say, maybe someone who knows the process but isn't necessarily a model builder can interact and query these simulations to understand the best way to run the processes. So the example I have here is basically like a slider where they're varying the rotations per minute or the mixing speed of a vessel. And they're trying to understand what the final influence of that different agitation speed is on something like a particle size distribution or viscosity for their formulation, which is often critical for a lot of like distillation, polymerization, or even cosmetics manufacturing processes. Under the hood, the way it works in our architecture, kind of advance this slide just to show all of it, is on the very left, we ingest data from a variety of different sources. We then create data pipelines via like scripts or data processing rules to clean data as it comes into the system. So if it's like some type of Emerson or Honeywell system, then do this. If it's an Excel-based file, do this. And then we basically use a combination of physics-based models together with data to build these simulations of individual processes. And then again, we're publishing applications. And typical use cases for us vary from predictive scale-up, which is, okay, I've got a lab-based process. Maybe I'm running it at, a couple liters. In small scale, it might be like a few hundred milliliters, but I need to know what happens when I'm going to be running my process at 10,000 liter or 100,000 liters. What's the best way that I can scale up my process and actually optimize how I'm going to be running it when I get to commercial scale, when I'm scaling up? Second most common for us is also like real-time CPV, our process verification. That's more of like an FDA regulated terminology and quality control. So that's the typical use case where, if it's a batch-based manufacturing process, I'm halfway through my batch. How's my quality? Am I doing okay versus the last 30, 40, 50 batches that I've ran? If it's a continuous process, it's constantly monitoring the actual like outputs of the system. And the digital twin is making a prediction of how the actual quality should be and will be relative to these lab tests that you have. So a lot of our customers have lab tests that are very expensive or costly, or they may only run it every 6 hours or every 12 hours in a process, or maybe faster. But we can give them real-time insights into that quality that the lab tests cannot. And oftentimes we're informed by the actual lab tests themselves. Last category is going a level deeper, which is not just monitoring the quality, but actually giving set point recommendations back into the system. So you need to change your flow rate. You need to change your pH. Here's how I would shift the temperature in order to maximize my yield, maximize my costs, or minimize my costs, and reduce things like your cycle time as well. Again, just fancy animations kind of showing the core experiences on the platform. One that's more designed for the model builder, and then one that's more designed for the average, let's call them like engineer, scientific, operating end users that just need a very simplified dashboard because they don't need to know how the fancy digital twins and models work and things like that. Obviously, we incorporate a lot of like AI-based experiences within the platform. So within the actual interface, a lot of the building is designed to be very low code. So if I have a process flow diagram and I have historical data, you can basically bulk upload this into our application and start asking an agent, what can I actually do with this data? And it'll begin to query and go through your data and start to make recommendations regarding the specific models that you can do, or even ways that you should clean up the data prior to actually building that model. So it's just empowering the everyday end users. We often find that there's a disconnect between the, let's call it them like the data science crowd, who's really good at parsing and working with data and building these models, and then the SMEs or the subject matter experts. And those are the actual engineers, the scientists, the operators on the plant floor or in the lab who really know the process, but it's probably not part of their job description to parse through hundreds of different data sets and build some sort of fancy, complex mechanistic model. So we can kind of bridge the gap and empower both of those teams on a common platform as well. Getting a little bit nerdy, if you guys are interested, a lot of our models that we deploy with our customers are for complex unit operations. And in these environments, traditional machine learning and statistical models will often fail. They don't extrapolate well, so they don't perform well in like these noisy environments where you have a lot of like sensors that drop off, or you may not have a lot of coverage as well. but we actually use the governing engineering principles, things like the thermodynamics, the fluid dynamics, or even the reaction chemistry of the things that you're building, together with historical data to build what's called a hybrid model. Advantage of these is that they're explainable. Engineers can understand the why behind the model. They extrapolate well to novel environments. So if you're doing a predictive scale up, or you've got a new product that you're introducing to the market, but it's like 25% similar to some of your last products, then you could still carry over that tribal knowledge that you have within your engineering staff. And then it's obviously very scalable. Typical use cases for us across the value chain, again, core verticals, pharmaceuticals, cosmetics, polymers, adhesives, a lot of specialty chemicals as well. In pilot and R&D scale, which is more like of a laboratory environment, we're mostly focused on optimizing the development speed. So reducing the number of experiments teams need to run in order to characterize a process, and then doing predictive scale up and tech transfer to actually understand how that process changes as a function of scale. And then virtual experimentation and formulation. And that's more like, like a what if analysis. So I'm here. What happens if I make this change? What's the predicted influence on my viscosity, my quality, my yield, and things like that? In commercial scale manufacturing, we're more focused on real-time optimization and monitoring, like I walked through before, and a lot of golden batch analyses for these batch-based processes, which is very common for us. And that's just basically trending how your historical batches and processes have ran, and then doing an analysis using the digital twin that gives you recommendations saying like, hey, you're 5% higher here, you're 3% lower here. You should probably make these changes in order to meet your target quality spec or optimize yield and optimize cycle times. I definitely don't have time to walk through the entire case study here. I'll flash some of the details. We work at this large Fortune 500 manufacturer, chemical type of manufacturing process. It was basically like a reactive distillation. They had like an oil water separator, a reflux tank. They were basically making a very high value, high margin type of monomer and polymer product. With Base 2, we were able to build a model that accurately predicted the purity profile over time, and then give them insights into that target product purity to actually help them reduce the cycle time down from around 8 hours, 8.5 hours, it varies by batch, to around 5 hours and 40 minutes, or 6 hours in this case. So around a 30% reduction. Then we also gave them insights into how their batches were varying over time. And once deployed, we were able to actually notice a batch that had deviated and prevented them from getting any product loss by giving them a recommendation on what they should change mid-batch before the failure actually occurred. In terms of financial impact, we worked with them to do sort of like a ROI, or an investment analysis. And across the cycle time reduction, the material reduction, and the reduction in batch failures, we were saving them around $7 million a year with a deployment in Base 2. Last thing I'll say, I don't know if I'm overtime or undertime, I guess I will find out, is the way we work with customers is we typically like to do like proof of concepts. So we'll focus on a single use case, really develop the actual business case in the ROI, focused on like a single product line or a single plant. And then after we've demonstrated the success there, we like to scale from there. We find that a lot of our customers are very, let's call them conservative or risk averse. They're dealing with high value, high margin, high impact products. So they really want to prove out the value of technology prior to deployment. So this is how we've kind of modified our commercial model as well. And we provide IT and engineering support throughout this process as well. That's all I had. Does that make sense? I want to make sure I'm good on time too.
You're good on time, Kiefer. Yeah, well done.
Awesome. Perfect.
We do have time for a couple questions. Anyone's allowed to hop on. I will run a mic to you to make sure he can hear us.
Lovely.
Do you build the virtual twin, or do you build the virtual twin?
Good question. We do both. So we have some customers who what we call like power users. They may have like an internal modeling team that builds the digital twins, but we have other customers that are less, I don't want to say sophisticated, but maybe not have those internal capabilities. And then Base 2 will act as the service provider where we'll build the digital twin on their behalf and let them deploy it. So we've seen both.
Yeah.
So is this all web-based? Is there software that we run on our machines, or are we uploading all the data to you? If so, who owns that data once you have it?
Great question. We can deploy in 3 ways. Our POC preference is on our cloud on AWS. It just makes our deployment easier. The second preference, and that's usually post POC, is on the customer's cloud environment, Azure or AWS, whatever works. For advanced process control capabilities, we're actually writing set point back to an equipment. The cloud is too slow, there's too much latency. And in that case, we'll actually deploy in a containerized environment within the IT or OT network and make those recommendations and make those changes. To your second question, we have no IP or ownership regarding the models or data that are uploaded and deployed on the platform. Our full ownership is on the capabilities of the platform itself. We work in environments that are very IP protective, like pharmaceuticals, and we wouldn't be able to work in these environments if they weren't comfortable in uploading their data and information into our platform. So,
Thank you.
does that answer the question? Yeah.
Yeah, very good. Any other quick questions here? Yeah, we'll do one more.
So say your model predicts something that we would never have considered. Is there a way to go back and look at what the physics they're looking at is to kind of understand why they are making that change?
Yep, definitely. Two things I'll say is one, I'll go back to this slide because I think it's a good backdrop, is we can actually constrain the recommendations coming out of the system. So those can be absolute constraints, such as this temperature, like a temperature over 50 will never make sense. Or they can be relative constraints. Like if your pressure is this, then your temperature must always be this. So it's a function of other variables. And we can ensure that the outputs of the simulation always respect these constraints. To your first question, when you're looking at the actual model recommendations, because it's hybrid, you can understand the feature importance or the reason why a model is making the decision that's making. And we can actually output something like 95% of the prediction or the variability of the prediction is driven by the change in your vessel size, for example, or your mixing speed. And at any point, you can always go back and retrain the model, and you have full control over this too.
Let's thank Base 2 for presenting.
Awesome. Thank you,
Thanks,
folks.
Geever.
Appreciate the time.
As a reminder, we will throw up the connection form there at the end. If you want to connect directly with any of the startups we have presenting here, that is the best way to do it. And we're happy to pass along any of the materials you've seen today at any point during the event. At this time, would love to welcome Cognac, our next presenting company. We'll be joined by Daniel and Lexi. Cognac is a computer vision AI platform that helps industrial teams turn visual data from cameras and operations into actionable intelligence.
Yes, hello, thank you. How's my audio coming through?
Loud and clear. Go ahead.
Great. All right, I believe Lexi's going to be sharing the presentation.
Yep, having a hard time sharing. I'm getting an error. Give me one sec. Actually, Anne, are you able to share?
Give us 1 second.
Okay,
Working on it.
Lexi, I'm going to make you a co-host and see if that gives you the power you need.
Okay.
If not, I do have your deck. Okay, Lexi, try it one more time, and if that does not work, we'll pull it up from my end.
Okay, it's saying I need to quit and reopen. I can join back the call.
Sorry, say that again. Oh, okay. Thank you for your patience. Awesome.
There we go.
All right,
All
Daniel,
right.
yours.
Absolutely. So thank you, Lexi. My name is Daniel Atherton Moore from Cogniac. I've been working in various inspection and process automation spaces for about 20 years, and I'm happy to present about our company and what we do. And the gist of it is that we want to help turn any image data into something that's actually useful, functional, actionable for the customer, whether this is because it's hard to have eyes on the topic the entire time, whether because people are making mistakes all the time, whether because you just don't have enough people for doing these tasks. We provide a system for building custom convolutional neural networks, so not quite large language models like Claude, but really specified systems for your data and your images. Next slide. So a little bit about our background, and this is relevant. We were actually founded by one of the co-founders of Ruckus Wireless, which if you hadn't heard about them, they were a company that worked in enterprise networking spaces. And they said, well, we basically have the same like antennas, same hardware, but how do we do things better? How do we apply skills, mathematics, customize algorithms, and then apply that to wireless? Well, they did a pretty good job because they sold for about $1 billion. And it turns out that AI run on data. So those same algorithms, the same ideas of saying, well, okay, a lot of people have the same kinds of algorithms, but how do we use them better than anyone else? That's where Cogniac came into being. In fact, about the time that Cogniac was started, there was this wonderful research paper called Hidden Technical Debt in Machine Learning Systems. And so figure one, only a small fraction of real-world machine learning system is composed of the actual ML code, as shown by the small black box in the middle. The required surrounding infrastructure is vast and complex. The data configuration, data collection, data management, data tagging, deployment, infrastructure. Well, that surrounding ecosystem was exactly the specialty that was brought to bear on the problem of artificial intelligence. Not just, hey, we've got an algorithm, because it turns out everybody has an algorithm, but can we build that architecture around it and automate that process for people that have better things to do, right? So the simple goal is to have a system where anybody could build a process. And it really doesn't matter what that process is because we're using your data and we're customizing the models that are generated to your task. If you want a dog finder, draw a box around a dog. If you want to find rusty pipes, you draw a box around a pipe. And it doesn't matter whether you're the person working right there plant side next to the machine. It doesn't matter whether you're the data scientist in the back room. We provide tools that are relevant to your skill level, your familiarity, and your expertise. But we really want to leverage, right, an expert's ability to look at something and say, that's a problem. Oh, that's interesting. Oh, that's a concern. We basically try to bake that in directly into the platform. And so we've been able to apply this across a huge laundry list of use cases, right? We're like the #1 rail inspection platform in the United States, but we're also working in casinos, counting chips. Casinos, as you may know, famously casual about how they handle money. So when they wanted somebody to look at the way they handled their chips and their money, they said, we need something that is basically perfect all the time. And we said, yeah, let's do it. We are always solving the hardest use cases, right? Where someone says, well, traditional vision isn't really working for us. What do we do here? The answer is, well, you turn to AI. And so because we can build custom systems, it doesn't matter how complex the use case is, or even what the use case is. If there are images, if it's someone's job to look at something with their eyeballs, we may be able to automate, iterate, and improve on that. And we've done this for quite a wide variety of actual customers as well. So it's not just theoretical, right? We're looking at everything from sheet metal to raw food to cooked food to trains to the casinos, as mentioned, but also our energy infrastructure, even medical devices, but also medical paperwork and working inside testing environments for hospitals and medical use cases. Because we're always building things that are custom, and we built a generalized system that says we can work on nearly any data, we're able to cover both within a vertical, but also a wide variety of verticals. And Lexi, I'll hand it to you.
Yeah, so we hear a lot like AI doesn't get you to production, AI isn't mature enough to add value, and we're seeing the exact opposite of that. We're solving really hard problems. We're solving hard problems at scale, and we're monitoring situations 24/7 with cameras. We have one client, a few clients using this in multiple different ways, but we're going to dig into one here, who's looking at raw meat coming out of a grinder. And they're looking for specific problems in this raw meat. So foreign material is one, and sometimes these can be as small as like a hair or a glove, things like that, inside of a very large auger. And as you can imagine, this is an ROI issue for them. So if they have detected foreign material, they need to do a recall if it gets that bad, or before that, they need to eliminate and throw out all of the raw meat that was impacted by this issue. So in order to do this, we need cameras that can see really small things, whether that's a hair, whether that's something in there. We need to integrate with their existing systems. So this particular client actually already had some cameras. They weren't necessarily being used for this. They were more of a security. But how can you integrate that to actually do two things at once and leverage what they already have on site? And they need to do this 24/7, and they need alerts right away because they want to get rid of a whole batch of meat if it's been impacted. So in order to just set one thing up, we need cameras, we need to see it, we need the infrastructure to do this at scale all the time, and we need the AI models to actually correctly say when there's something wrong. Because if we're sending results and alerts back to them that are actually just part of the meat, we're wasting everyone's time. So we're solving a really hard problem here with a real clear ROI. But this is just one of many, many problems that we're trying to solve. So one more general problem is a lot of documentation and paperwork. And we see this across clients in so many industries. The cool thing about this is you hear about Vision AI and you think you need the best cameras the market can buy. And a lot of times that's not the case to actually get ROI. You could take pictures with your iPhone. We have a client that is doing bill of lading, and actually the truckers just take a picture on their phone and upload it into a system that they have. And with that, we're able to process hundreds of thousands of these documents into any data analytics that they want to do. So where did that bill of lading come from? What type of material was that truck carrying? We can take OCR off of this and then do cool analytics that the company didn't even know that was valuable to them. So for example, what company of truck came in X number of times over X quarter, and is that more or less than last quarter? Does that impact some kind of revenue? There's all kinds of things that we can do with this type of information. And all that is within our system because the AI models are able to sort and classify however is valuable to you. And like Daniel showed, all this is customized. So if you want to build a model that sorts the bill of lading on name, you can do that. You just have to box it, right? Like anything that you can see, you can do something cool with. OCR is one example. We can do segmentation models. We can do classification like the box you saw. And all this continues to improve in our system. As you can imagine, there are many, many use cases here. So, Walt Disney always says, if you can dream it, you can do it. What we say is if you can see it, you can do it. So you can think about parts of your life where you're using your human eye to make a judgment call. Think about how you could put a camera and train an AI to do just the same thing so that you can focus your time on something bigger and better. I know Daniel mentioned life sciences. One really cool thing here is, for quality control, we're seeing a couple life science clients look at the outcome of tests. So say they have a vial of something and that changes a slightly different color if it's good or bad. We're able to pick that up because the camera is able to notice those color differences. One particularly cool manufacturing use case that we have is we're able to determine splits on stamping. So this is a typical picture of what we see, and the split, you can barely see it with your human eye, but we have cameras that are really zoomed in. And again, once they're boxed and trained, we can detect something every couple seconds. And so we've actually gotten to such a point with this client where they're able to pull humans off the line and rely on our system to send an alert to a stack light that says red, something's wrong. And then that image actually comes up on a screen next to them that shows where it's wrong. And they can make a judgment call right there if they want to continue or actually stop the line, take it off. All right, and what do we do with that material? We can take that output of the structured data from the AI system and do anything with that. But one particular integration we have is with SAP. So we can take that and move it into the systems that you already use, completely eliminating the need for human reporting in that loop. And one last slide here, there's really endless ROI in this system across many, many industries. So we work very closely with some of the major rail companies in the United States. We're preventing derailments. We are involved in logging and making sure that there's quality control, that the logs are the correct size. We're operating sites where people no longer have to travel as much to those sites. All these things are possibilities with the Cogniac system, and they're really real production-ready, ROI driving use cases. All right, and that's everything. We're happy to take questions.
Any questions from the room? Anyone other than Philip? Philip, take it away. You might as well.
So, without understanding the mechanism that the AI is making the identification, say something gets passed, how do we go back and troubleshoot what went wrong? Say it's you're having it detect for the size of logs and it didn't catch it.
So some of this is simply that you can review. We are always looking to improve the data set. So we might sample a log and say, hey, this log is difficult. We're not sure that the measurement was exactly accurate. Please review. Some of it will be if there is, quote, an escape, which we, of course, are trying to minimize below whatever threshold the customer already has. That may be caught through however way it was caught beforehand. So like with sheet metal parts, if you, even with the human inspectors, you might see, oh, we let a bad stamped sheet metal part make it down the line. And with a human inspector, we get 100 of those per month or whatever the threshold is. As long as we can reduce that below 50, below 20 per month, we've created an ROI even if there is the occasional escape. And then that image can then go in as training data to say, hey, this one got through. Let's try to take it from 20 to 19, right? So it's a continuous improvement process. As a matter of fact, all of our active use cases, it's not like we produce one model and it's off to the races. Usually we're iterating and producing thousands of models for each step of each use case.
What else do we have? I've got one. I'll throw it out. You work in a number of different industries, building custom products per client. Are there learnings from one system that translate to another? Do you collaborate between industries with your products?
Well, I guess I should clarify. It's usually the end customer themselves that we are training, right? Because they're the experts. So we want them to be looking at the images and providing insight directly into our system. So when I say that we build, we provide a platform that the customers build within. We can certainly help with that. We provide the training for that. But in general, there's no data transfer from one industry to another unless that's contractually agreed upon, because every customer retains ownership of their data and their images.
Yeah, what we do learn on though is like which cameras we can recommend that tend to work best under certain types of conditions. And, the cameras are not really our value add here. It's really the AI models. But another thing is determining between whether you want to use segmentation, or classification, right? Which type of AI tends to work best in different use cases. And the thing about the Cogniac product is you can, in the same workflow, you can spin up multiple tries of the same thing and run them together, see which one actually does best on test data, and then take that one and promote it to production. But there are lessons learned of where to start to kind of cut off some of that iteration.
Any final questions? If not, help me thank Daniel and Lexi. Appreciate you guys.
Thank you.
Glad to be here.
With that, we'll take a quick 5-minute break here. Feel free to use the restroom, grab some refreshments. For our folks online, we will be back in just a second and kick off with 2 more startup presentations, and then you'll hear a bit from me before we conclude today. But I appreciate it. All right, we are about to kick back off, so grab a seat and we'll jump to our next pitch here. All right, with that, we will have our third presenting startup here. Love to welcome Six Systems. Syed's joining us. They are building agentic AI for industrial optimization and control using specialized agents, advanced models to help manage complex physical systems. Syed, take it away.
Yes, I guess this is Christopher. I'm here. I'm going to be. I'll do the voiceover here while Sohail gets our demo up. So what I want you all to understand here is that what we're showing you is an implementation of an agent orchestration system that kind of works like bees in a hive. Each bee, pretty stupid, not so useful, right? But thousands of bees working together can do some amazing things like build a hive with all this complex geometry, do some really complex engineering, do complex chemistry, creating honey in a multi-step chemical process. So very much like that, we have these multi-agent systems. Now, this was based on some of the work that I did almost 30 years ago in the technology that went into Siri, Apple Siri. So based on AOSA, this agent orchestration allows us to do some complex engineering steps with agents that are not just LLM logic, not just language logic, but actual mathematical logic. So we have an agent doing thermodynamics. We have an agent doing pipe sizing for a plant. And all of these together can work like a group of engineers to design a process in a plant or redesign a brownfield plant for, let's say, ammonia production. Let's do a green ammonia production here. You're seeing this being typed in right now. And what's going to happen is this is going to spin off and spawn off dozens of little agents that will actually go out and do all of the thermodynamic calculations, all of the physical calculations from physics up, and then combine these into an actual plant design. So we're talking about tens of thousands of hours that it would take for an EPC company to go and do this exercise that you're going to see happen in about, I'm guessing about a minute to design a green ammonia plant here. And we could have been more exact on different carbon output requirements or different streaming requirements or different compressor requirements on the plant. We didn't here. We let the agents go figure that out for us, but we can constrain the problem as much as we really want to. So you can see the agents instantiating templates for design, proceeding with the design, and a flow sheet now to replace the steam reformer with an electrolyzer so that the plant becomes a green ammonia plant and not just a normal ammonia plant here. So updating the reformer to be an electrolyzer, modifying the stream accordingly. So you're seeing these agents communicate with each other to say, look, auditing something and saying this doesn't work to make it green. We're going to change this to that, and working together to create a flow sheet, which is going to be the end of this process here. Flow sheet solved successfully. Now we got detailed results, creating the final documentation. And now you're seeing this here. So these things work together, encounter issues, talk to each other, work it out, just like an engineering team would. And now we can go and look, I think, at the actual flow sheet design. Has it come out yet, Sohail? Go into the projects. Here's the ammonia synthesis. And so you can see here the design objectives that it's came up with from that statement. We're trying to, it said 100,000, don't go so fast, 100,000 tons a year. With the feed specifications, 98 Kelvin, 1 atmosphere, compositions, product specifications, design assumptions, etc. These translate into design objectives. And here we said we want it to be a green objective, a green ammonia plant. So it's showing byproduct values, the compounds that we're going to use to actually do the synthesis here, the various streams that are going to be in that pipeline. And then at the end of the day, here you see the different compounds that we're using, the reaction modules. Here you see the different feed, splitter, product. And at the end of the day, you will see a flow sheet. And there you go. Here's the design of an actual ammonia plant in minutes. And keep in mind, like I said, this is tens of thousands of hours for an EPC company to give you just the preliminary engineering to come to this diagram. So what we're able to do, and mind you, this isn't just giving OpenAI a prompt. This is having dozens of physics-based modules give us the actual numbers here, the actual equipment that we're going to use, everything from the ground up. And we can even do sizing. We have all the physics, and we have the history of every calculation that we've done here. Just like a human engineer would go out and run a thermodynamic model, you can see we have exactly the physics visualizations of what we've done here. The air feeds, everything that a normal engineering package would give you, that the engineering teams, that would be tens of people working over months to do this project, we can actually use an agentic system to deliver the same project in days. And we are doing an exhaustive search of the search space of all the possible plant designs. We're not just taking the 4 that a certain engineer did last year, or the thermodynamic model that was my favorite when I was in grad school. We're doing an exhaustive search of the space, so we end up actually being able to intensify and get better designs. So it's actually a better result than you would get with a typical engineering firm. So we're able to actually really disrupt, and we can do this for bio, we can do it for chemistry, we can do it for oil and gas right now, energy sectors. Eventually, we're going to be able to do this for physical discrete manufacturing as well. But we're starting in the chemical and biological space. That's $1 trillion manufacturing building. Just the EPC piece of that is $1 trillion business as it is right now. And there you go. I think we can end the demo here, and maybe I'll open the floor to questions. We have a pitch deck that we'll send to you after, but we felt that actually showing you the system working to design a plant would be more interesting than taking you through PowerPoint hell for a couple of minutes. Thank you. Open up to the floor for questions.
Any questions? You gonna flake out on me, Philip?
So what would be the application for existing manufacturing facilities?
Oh, well, it would be so if you're familiar with the EPC market, engineering, procurement, and construction, $1 trillion industry, we would be doing the E part of the EPC. So we would either work with an EPC company that's doing the procurement construction, or alongside an end customer, like an oil and gas company, or an ammonia producing company, or the investors investing in a plant, or the investors investing in a bio plant to make an Ozempic, for example. Something like that. We're working with right now a company that's doing a bioproduction facility that they've been funded for with a major bank to produce, to take sawdust and turn that into food. And we would be doing the engineering piece of that and delivering the design. The design itself, if you're familiar at all with how this industry works for designing plants for manufacturing, basically you deliver the design kind of like an architectural drawing is delivered for, houses. The design itself is IP. And you end up with a recurring revenue stream of 1 to 3% of the capex of a plant for the life of the plant. That's kind of the business model that's accepted. It's already, a line item. If you're going to go build any kind of manufacturing plant, it's already a CFO line item that you need somebody to do the engineering package, somebody to diligence that package, and we can do that here. We didn't show you this, but the entire economic model is also calculated here, so we know all of the equipment prices and everything to actually give you give the investors into the project an idea of whether it flies economically over time. We can do full life cycle analysis as well. Does that answer your question?
Yeah, thank you.
Anything else from the front to the back? Well, if not, Chris and Sohail, really appreciate you guys hopping on. As mentioned, we'll share materials after. If you're interested in any follow-ups, happy to make those connections. Thank you both.
Great. Thank you much.
Thank you so much.
Appreciate it.
Take care.
Bye
Bye.
now.
Our last startup this afternoon is a company called Industrial Next. We'll have Lucas join us here in just a second. Industrial Next is a company bringing autonomous manufacturing systems, smart cameras, and robotic guidance to automakers and advanced manufacturers. Lucas is giggling. It looks like he'll take it away from here.
Yeah, thank you for the intro. And I will not save you from PowerPoint Health. So you're getting some slides here. If I can figure out how to share them, of course. There you go. So most factories today are running 21st century products on 20th century equipment with 19th century flexibility. And it really shows. You see it in missed ship dates, overtime bills, scrap. You see it when your best engineers are spending their time fighting fires instead of actually improving the product. I'm Lucas Pankau, co-founder and CEO of Industrial Next, and we built Industrial Next for one reason. We want to turn that chaos into an ROI machine, just like we've done at Tesla in the past. We've created AI-defined factories and are working with some of the largest manufacturers in the world, including the ones who make Dell, Apple, Tesla, and OpenAI hardware. And our AI is not just a demo or a science project. It's actually a system that sits in your existing factories, guides robots in messy real-world conditions, and ultimately gets better every single shift. If you run manufacturing, you're under pressure on three main fronts. Labor is expensive, especially skilled operators and technicians. Product life cycles are getting shorter with more changeovers, more SKUs, and more retooling. And customers expect near zero defects. Traditional automation struggles in this world. It's great at repeating the same motion a million times, but it's really terrible when parts vary, the fixtures aren't perfect, or marketing decides to change the product again 6 months from now. So the default answer often becomes, we'll just throw more people at it. And that works until it doesn't work anymore. We take a different approach. We deploy high dexterity robot work cells powered by vision and AI that can see, understand, and adapt live to the variability on your line. Instead of hard coding every motion, we train our models on your factory reality, your parts, your layouts, and your failure modes. The system learns from every cycle, successful or not, and continuously improves. The core idea is simple. Your factory is not a static project, but a living data source. If you can close the loop between what actually happens on the line and how your line behaves, your returns compound. Let me show you what this looks like. Let's display here. This is a replica work cell like you would find in any modern factory running with our autopilot system. You'll see our robots effortlessly handle part variation in position and orientation, not because we wrote 1,000 special cases, but because the AI actually understands what it's seeing and what done right means. The task here is placing a connector cap on a tiny and delicate ribbon cable with a phone's volume button. That's actually an iPhone in the video there. And it connects that volume button cable to the phone's main printed circuit board. And here's a model. Here's the same model that you saw before, but tackling a different task. Here we are inserting a DIMM memory module into a server motherboard. You need very precise alignment, firm seating into the slot, and confirmation that the latch clicks closed. This is what we mean by AI that underpins a flexible assembly line. The same underlying model that handles the previous task can also perform this one, still at 1x speed, still fully autonomous. And that's the unlock, really. One model, many tasks, and no bespoke engineering for every part. What you just saw was fully autonomous with no pre-programming. And this is just the tip of the iceberg. Under the hood, the system is performing trillions of calculations a second to understand what it needs to do and how it's actually doing it. But from your perspective, you don't see models or parameters of AI. What you see is real-time unit economics for every line, a collection of robots that can handle more variation than traditional production line, and a path to roll out successful playbooks across your other lines and factories. This matters because once you digitize not just the product, but the factory itself, in other words, focus on the machine that builds the machine, you can understand changes before you ever make them on a production floor and launch new SKUs within days rather than months. You stop treating each production deployment as a custom art project and start treating manufacturing as a software problem with real benefits. If you're curious about the ROI, about what I've shown you, in Vietnam and Thailand, even with local labor rates, we see payback periods of less than 22 months. In the Midwest, in the US and Canada, we see a much shorter payback period of less than 9 months. And beyond financial returns, on a typical robot workstation, we also see better yield with less scrap and better uptime and flexibility along with full digital traceability. All that comes free with the robots. Our technology is the enabler for the rethinking of manufacturing. And if you're a manufacturer, you already know that real competition long-term isn't just someone with lower cost labor. The winners are going to be the ones who can learn the fastest, who can spin new products, reconfigure factories, and improve cost structures faster than anyone else. Our vision is that in a few years, it'll feel as strange to run a factory without our AI autopilot as it would feel today to run a logistics network without tracking or route optimization. Industrial Next is how you get from where you are today to that future, starting one line and one deployment at a time. If you're thinking, we tried automation, we know the pain, but like if this actually works, it changes the economics of our plants. That's really the conversation that we would like to have. Bring us your hardest production line challenges, the ones with the highest mix and annoying variability and constant firefighting. We're Industrial Next. Thank you. Any questions? Comments, concerns? I'll take those too.
Maybe we start with concerns. Any concerns?
Too many robots.
Loading. They're loading. What's your most predominant industry where you've seen the most ROI on the shortest timelines?
Honestly, consumer electronics. We're deployed right now on a production line makes phones. And the product lifecycle for most consumer electronics is about a year. But then really the manufacturing time of that, if you consider like commissioning and changeover and all that, is only about 6 to 7 months. And with our technology, the really cool part, and this is not actually what we set out to do in the first place, this is kind of like a additional benefit, is that the commissioning time becomes much shorter. So now you can deploy the station much closer to the actual date of start of production, and it still works with the perfect reliability. And so that's really where we see right now the sort of the biggest drive. But fundamentally, a lot of manufacturing for electronics, consumer electronics, is very similar to medical manufacturing. It's actually very similar to automotive. My background is primarily in automotive manufacturing, and a lot of the things that we've done at Tesla and at Ford are very similar to what we see right now on like an iPhone or an iPad production line.
Aside from working with Industrial Next, there's obviously a large movement to reindustrialize the United States. What do we need to do to make that happen? What do we have to be competitive at to make that work in the US, maybe even particularly in the Midwest, from your experience?
So there are a few things, right, that drive reshoring. One is ultimately the geopolitical challenges of shipping your parts around the world a few times in the life cycle of product. But really what you need to replicate in some ways is the economics of manufacturing that right now you're getting, say, in Southeast Asia. But two, it's not just the labor costs, right? There's also a whole supply chain there that is localized in low-cost countries simply because of that low cost of labor. And so what we see, and this is one of the main goals for starting Industrial Next, is we want to be able to bring those unit economics from Southeast Asia for these kind of manufacturing tests to the US, be that in the American heartland, be that on the coasts, really anywhere in the country. And we can do that because if you sort of think about this from the automation perspective with smart robots, your main cost driver stops being the labor or the robots, it actually becomes the electricity that you need to run the robots itself. And there we can be cost competitive with anyone else. And so really this kind of technology, we see that as the enabler to really jumpstart that kind of reshoring, because you can apply it not only for that finished assembly, but you can apply it in every other part of the supply chain, because that supply chain you also need to bring here if you really want to reshore.
Awesome. Lucas, we really appreciate the presentation. Help me thank Industrial Next.
Thank you so much.
All right, so we are rounding third and heading home. We're going to throw up the deck here, and then I'll talk at you, talk with you, one of the two. Hopefully one that's more enjoyable for you guys. Before we close out this afternoon, and then I think we've got a couple other events later today, and we'd love to stick around and have some conversations. So as I mentioned at the outset here, I represent the ventures team at Plug and Play. So I want to do a couple things in the next few minutes. Also, we have a small enough group. If you've got any questions, just stop me, shout them out. Would love this to be more conversational than me just talking at you. But yeah, I want to do a couple of things. So I'll tie in some of the things that Brandon said on the Midwest perspective. I'll tie in some of the things that Lindsay mentioned, just to give you maybe a full rounded picture of what Plug and Play is, and then we'll talk a couple trends. So what I'm about to show you is what we would call, so it's our Q1 supply chain update report. These are reports that each of our teams across Plug and Play produce. It's one of our core products when we come alongside an organization like yourselves to support on external innovation. So I'll give you kind of the example of that. Obviously, there'll be some content of that's relevant to the conversation. You'll see some duplication of the technology that we just saw presented. And then I'll gloss over some of those because they were a little more technical than I'll be. But yeah, so with that, want to share on the Plug and Play side. So we mentioned, predominantly we're a corporate innovation platform. As a second piece, we invest quite a bit off the balance sheet of Plug and Play. So we're structured as a family office. I sit on the ventures team. That just means we've got 100 plus team members globally that are sourcing new technology, new research projects, from every region on the globe, and we invest in a portion of those. So you'll see a couple logos here. This is our dream team. So these are all the companies that we've invested in at some point, typically when they were anywhere from a $10 to $15 million company that are now worth a billion plus. So we call it our unicorn club. You'll notice we're a little more leveraged into software than we are some of the hard industries. Plug and Play has developed a presence, particularly in animal health and some of your physical industry categories, really over the last 8 years. So right before COVID and then post-COVID is when we've expanded there, just as a quick aside. And then I will reference again, each of the 4 companies you saw today, we've engaged in the last 4 years, and then our investors in each of those companies. I think the relevance to that is this is the core product of what we want to provide. So we've spent the last 4 years, our office launched by Lindsay and Stephanie and team 4 years ago, focused in animal health, as you heard. We would love to expand that to other industries. The great thing about working with Plug and Play in any of our offices is I can collaborate with any of our team members globally. So this is why we want to put on this type of programming. This is something we haven't done before, something we would love to do a lot more of. As Lindsay mentioned, I think the best way to utilize our resources is to bring us problems. You noticed each of the startups that presented today are solving a specific pain point. I've got a list of 120,000 of those companies, all that have been vetted through our network or have already worked with one of our corporates on a global basis. We'd love to provide that kind of resource and talent to the region. This is a quick snapshot on the supply chain piece. So I mentioned Lindsay and I are currently focused on animal health. This is a complete set of supply chain partners that we work with globally. You'll see, again, kind of the staggered nature of our growth on that, as I mentioned. What I want to circle back on a bit on some of Brandon's comments, and you heard it from Lucas there too as well. I think particularly over the next 5 years, the reindustrialization in the United States, plus the demand on the labor side, plus the fact that we're shifting the constraints on technological adoption, I think this is the perfect time for regions like Kansas, for regions like Topeka, to get into these specific industries, stake a claim, and find a niche to attract new technology. That's obviously the core driver of economic development. This is something that we chat with Stephanie and team, with the Link team, with Department of Commerce about on a constant basis. But the piece that I will pull out from what Lucas said that we believe as a core principle across Plug and Play, and certainly influences our investment decisions, is that the constraint is no longer labor. In reality, the constraint on most systems will be energy. If you look at any of the AI systems or any of your robotic systems, right, it's not hard to draw the correlation of what Lucas was sharing. The implication of that is there are certain regions in the U.S. that have abundant energy, and there are a lot of regions that don't. And that will be, I think, the largest growing category or fastest growing category from a technology standpoint. That technology is looking for a home. I don't think there's any reason why that home can't be in Kansas. And I'll give you an example or two of this. We've got 20 plus offices now, Plug and Play, across the U.S. Of course, Topeka is not the only economic development group that works with us to attract new technology. We work with now 5 offices in the state of Texas that are all interested in similar application. Again, I've got a resource of 120,000 companies. I'd love for some of those to come to the region, and this is how I think we do that. But again, I just want to clarify, this is the framing on how we view the problem set, where we think the opportunity is, and then I'll go over here in the slides following, specifically on the supply chain side, the domain that we're chatting about today, AI and manufacturing. What you're about to see is where we are deploying our capital. This is where we think the emerging technology is that will end up creating the next 5 to 10 years of growth. This is where we think it's coming from, and hopefully it's relevant to you guys. This is probably just the best chart on reindustrialization in the U.S. I think the number is 1.5 trillion spent collectively across the United States economy in the last 18 months on some form of manufacturing or manufacturing capacity advancement in the United States. That number is going to continue to grow for obvious reasons. Some are geopolitical, some are opportunistic. All of the startups you saw today are all opportunistic, not geopolitical. Again, we're shifting how we structure production and process automation in the United States, and I think this is a good example of that. Yeah, there's a couple good Goldman Sachs reports on this that I think we think highlight the opportunity here. Let's chat maybe a quick framing. Again, I'll keep this detail light because you already saw it from the technical members of our startups pitching. Digitalization dominated the last decade, maybe even the last 15 years. Again, I'm not going to talk at you because you guys work with this on a daily basis. We went from analog to digital in pretty much every facet of operations, and this is across every industry, but obviously hard industry and manufacturing is a key part of this. You guys may have worked with a couple of the folks on the screen. Again, the whole concept is taking stuff that was on charts, stuff that was done manually, and putting it into a digital system. That's great. And you can typically find a number of efficiencies off that. The constraint is still most of that data lives in silos. It's really hard for it to talk to each other, and there's still some coordination issue. And so we think that's the next generation of process automation. It's moving from digitalization to fully autonomous systemic work. So you saw the reference of agents from pretty much every company up here. Hopefully you have a better idea of digital twins. I know that was one of Brandon's questions, and we had a couple companies kind of describing that. That's the archetype of new solutions. And I think maybe the best way of framing this is we are investing not in general AI solutions, but in solutions for a very specific task. Jason also referenced this on the Gemtech side. Where he's like, don't try to apply generic solutions. Find a specific process, a specific task, and automate that one instance in the organization. Any of the companies that we work with, we happen to work with a number of them, that succeed on the corporate side tend to have that process. And I think maybe the overlay on top of that is everyone's tried to figure out an AI strategy in the last 2 years, last 4 years. It's typically C-suite down, and usually it involves everyone using ChatGPT. That's fantastic, and there's some efficiency gains there. The challenge is most of the time our systems still don't talk. and those systems don't have access to the right data, or we're trying to apply a generic solution to a specific problem. I'll just reiterate, we think the opportunity across manufacturing in basically every industry is to find a specific task, a specific process, and reframe how we think about approaching that. And so I think my recommendation, or hopefully the recommendation following today's presentations and speakers, is to find something specific in the organization and re-underwrite how we think about operationalizing that. Meaning, when we move to an agentic system, what processes can we completely automate across the organization? We're doing this on the plug and play side, where we're completely knowledge work, and we think it's obviously relevant for physical industry as well. Couple just top line trends. Again, I think the next 5 years, lower hardware costs. We've commoditized, I think, intelligence as well. We've certainly commoditized software. Anyone who's messed with a coding agent understands what I mean by that statement, whereas it's just incredibly cheap relative to the last 10 years to generate a lot of these systems. The companies that succeed are testing those on a regular basis. Agentic workflows, again, this is taking existing data sets and automating the entire process of what that looks like. I'll go through a couple examples in a second. And then you obviously got a couple examples today on the vision side of things. Give an intelligent system context on the problem, and you'll start seeing some really good results. This, I guess you could probably call it a slight competitor to Cognac that you heard from a second ago. This is just a really specific example of another company that we've worked with over the last 5 years. This fully automates warehouse management. So they've got a handheld component for physical members of a warehouse team, as well as a full tech stack, particularly on the vision side. They can automate the entire shipping and handling process. So again, this connects and integrates to any of your existing warehouse management systems. Again, what you're seeing here is just automated tagging and dimensions and quality assessment of anything that's rolling through the doors or anything that's in the scope of vision. Again, some of you guys are probably familiar with some of these types of systems. I'm using this as the example of they've been very, very successful in our network working with our set of corporates. I think this is a great archetype example of the types of solutions that are going to define the next couple of years across supply chains and automation. I covered a bit of this a second ago. Unified real-time data is, I think, the big breakthrough for any organization. It's easier when you're a smaller operation, smaller organization. Find ways to get your data to talk to itself and give your intelligence layer access to that data in real time. You'll start to see the benefits. Horizontal coverage and then automated decisioning. Again, find a specific task in the organization, find a way to automate the process and automate the decision-making piece to increase cycle times. This is another good piece. So we've obviously had IoT sensors, new data streams. We're all familiar with a couple of those. I assume each of you guys has examples in your specific field of reference. Genlogs is a really interesting company that we first invested in 2 years ago on what we think is maybe the next generation of sensor tech. These are a couple guys who were formerly working intelligence, one for NSA, one for CIA. They've gone across the United States and deployed 800 cameras like you would deploy billboards along major intersections and highways. They run all of that data through a centralized network and then sell access to the reporting piece. For anyone who runs logistics or supply chains, you understand the importance of this type of data. There's corruption issues, on truck data or even company data. And so the example, they worked with one of our corporate partners, Werner, down in our Arizona office. In the first 6 weeks of use of Genlogs, 41 unauthorized usage indications that they were not previously aware of, and then $3 million uncovered costs. That was one of the best use cases we've seen from one of our portfolio companies. We were pretty excited. Again, how are we using data? in different ways. How do we get that data to talk to each other? How do we get that into a central platform where we can make decisions off that data? You're going to hear me repeat that pretty much on every slide here. As a quick reference back to what I mentioned, this is how we view the space. This is where we're investing. This is where we think the key technologies will be here in the next 5 years. I'll brief over this. I just talked about it, a second ago. Maybe the other analogy I draw is, I think for most of you guys, or for most of our large corporates, they show up for the agentic capabilities and the automated processes, and they stay for the network. What do I mean by that? If you've got a procurement agent that can source from all 100 or 200 of your suppliers and can cross collaborate and price compare, and ends up getting you the best price on a specific piece, and then manages the supply chain risk plus the shipping cost, right? You're going to end up getting a more efficient system. The unlock is when that system talks to another system, which talks to another system, and you end up seeing what the list price was versus what the PO price was versus the in-hand price. And you're going to end up getting a significant optimization across the entire supply chain. There are a couple companies working on this, but that's what I'm saying is we as we progress across the stages of technology, we're really good at automating specific instances this year. I think next year we're going to start seeing the complete restructuring of a lot of our systems, particularly global systems on a supply in the supply chain, where efficiencies are going to be well beyond what we can comprehend at the current moment. But again, just an example of what we can see. This is supplier discovery. The big piece, again, this is one of our partners that utilized ScoutBee as a part of their case study here. 6,800 plus new suppliers and a 95% hit rate. These guys are a fully automated procurement process, a supplier listing process. Again, just kind of a new system for how we do current things, moving from digitalization to agentic systems. I'll brief over this. The last bit that we're spending a lot of time on, looking for a lot of technology in, is the voice piece of this. This tends to be the easiest modality for any of us or any of your crew to interact with intelligent systems. And there are a couple new technologies that we've seen in the last year or two that we think really enable this. This is a category to watch for. It's something we're going to be investing in. And if it's interesting at all, we'd love to support you on that process. You'll notice every single one of these slides I've given you about 5-6 companies that have capabilities in what I'm describing. That's just the top companies we work with. Again, we run a high volume of startups and new technologies through the platform. What we're pretty good at, you also heard Jason reference it, is many of you have probably tried solutions. It's really hard to make them work. This is where Plug and Play comes in. We're an external innovation partner for a reason. We tend to have a number of different capabilities or have just seen a lot of shots on goal from other industries, and we can apply that to your specific case. We are best when you come to us with a very specific problem and we find a specific solution. Again, all of these slides, happy to shoot your way. You've got access to all of it. On a final piece, and again, this is just a clarification. So again, Lindsay and I still handle the animal health side of things. We've got a team of 20 plus down in Arizona and Texas that manage our supply chain and our advanced manufacturing team. They post a humanoid robotics report annually. They'll post a general robotics and advanced manufacturing report November of every year. And then later this year, they're coming out with our humanoid robotics report. Think of what I just showed you, but times 10 and to very specific sets of the industry. This is what we're good at. Think of us as outside consultants on that note. And then we run a lot of programming. The one that's probably most relevant to some of you and also close enough to where it's accessible is we've got an entire accelerator program we run on behalf of Walmart. Part of that is their new products. Part of that is their supply chain group. That will be hosted later this year. We run a lot of events, as Lindsay and Stephanie can attest. We'll run a couple more here as part of the link programming. So tune back in there. But this is just a couple examples of if you're interested in anything that you saw today, want to see more, want to take a deep dive, jump off the deep end. I got a number of ways to let you do that, and we'd love to support. That's all I got. Happy to take a couple questions, just as long as they're not from Philip. And I think maybe Lindsay will come back up here as well. Happy to hang out the rest of the afternoon. I know we've got some other programming. We love your feedback. So we've got that connection form. We'll pop it up here in a second. But yeah, tell us how we did. Tell us what you want to see. We've got more, and we'd love to hear your thoughts on startups. And if you want to chat with any of them, let us know. We're happy to make the connection. I saw a hand go up. That's a very good question.
You can take it.
We'll tag team it. We're a for-profit organization, so we make money through corporate partnerships. Think of us as a fee-for-service organization. So all of the partner logos that you saw, the 600 plus corporates, are all paying members of our organization. We work with a number of government entities. GoTopeka's one of them. We work with a number of municipalities across the United States. Their interest, like GoTopeka's, is how do we get smart people to relocate to the area. We're pretty good at that, since we like to say we know a lot of smart people. And then we work with a lot of academic and research as well. That's more on a collaborative basis. We've worked with DTI and K-State for a number of years. That's also through GoTopeka. Yeah, anything to add?
So our corporate partnerships kind of just keep the lights on. It allows us to be in Topeka and not in Silicon Valley. Our real bread and butter is like the venture side. That's how we make our money, is getting in early at the Dropboxes of the world. And when they hit it big, we hit it big, right? So that's how it keeps running. But I will say that with GoTopeka's partnership, it's purely on getting innovation here in Topeka up and running. So we are allowed to kind of, like, the first one's on them. Sorry, Steph. First one's on them, right? So they've allowed us to come here. They allow us to be here. They want you guys being innovative. So we can work with you guys, see if you like it. And then obviously we work with everyone from like the Walmarts of the world, but we also work with Bimini Pet Health in Topeka. So like it ranges, right? And Bimini isn't as involved as a Walmart and doesn't pay as much as a Walmart, and that checks. So yeah, happy to figure out a way, but our goal here is to help our region. And so any way that we can do that, happy to. Yeah. Philip, hit me with one. One last one.
I don't really know what it could be. So you guys know any resources to kind of better understand what the inner workings of AI is? Like, you say it's AI, it's the software. What's
Yeah.
it doing?
Yeah, absolutely. We've got a couple of AI trainings. We've got a couple of research papers that we could pass along to from our team. We've got a team in AI that we can pull some of their basic programming. We take our startups through a lot of it too. So happy to send over some of that stuff. And if it even makes sense, we can do like a basics behind the scenes of AI 101 kind of training too. So like those are the kinds of ideas that we want to hear, because we want to do more programming like this. So if something like that makes sense and everyone's like, heck yeah, let's go, we'll do it. No. Right. Absolutely. Well, and knowing where it has been and where it's going is different, right? Like you don't want to, what we know now is our Silicon Valley team knows way more than I do. And I'm okay at it. Mark's better at it than I am. But our Silicon Valley AI team is like Amit's crazy at it. So yeah.
Are you saying, like, what I'm hearing you say is like a workforce afternoon structured like this for AI systems, or how to use Claude, or would be relevant? That's interesting to you.
It would be like how to interface with it. But
Yeah.
Yeah, I don't know exactly what it would look like, but just to understand it better.
Yeah, absolutely. Absolutely. All right. If anyone wants a tour, Stephanie was supposed to come up here and give closing remarks, and I took the mic, but yeah.
Yeah, so thanks everybody for coming today. Like Lindsay and Mark mentioned, this is kind of our first time trying something like this here in this space. We are trying to tailor these sessions to what the community is looking for and what they're needing. So Philip, to your point, if there's a specific training, let's talk some more about that, just on what those things might look like or what the needs are. I know next week we've actually got one tailored to small businesses specifically in AI, helping. Thank you very much. AI-powered content creation for small businesses, because that's kind of a whole different sector than manufacturing or larger scale businesses. How do we help our small business operators really kind of manage and wade through what AI is and how to best use it for them? The big thing we've got coming up, May 26th, we've got Animal Health Expo. We've got a networking happy hour at the Knox, where some of our startups that are coming in for the animal health sector, many of those are international startups. And so that's an opportunity to come connect with them. On May 27th, we're actually doing a pitch and putt golf scramble over at the Iron Horse Golf Club. So if anybody's interested in that, let Lindsay, Mark, myself know. We're happy to get you connected. I'll probably be pulling together a team for Go Topeka. So if somebody's a golfer, because I am not, happy to do that. And then the big one, May 28th, we have our Lunch and Learn that will be here. Really kind of understanding with our startups what's going to help them make that move to Kansas. So we've got our Department of Commerce partners, we got our university partners, a lot of people in the space where we can have those conversations with those international startups that say, okay, what's it going to take for you guys to relocate? And this facility is one of those big things. And then we will do the Batch 10 Animal Health Expo over at the Townsite Tower. That's a larger event. We've usually got about 200 people that attend that. So an opportunity to hear those startups pitch, just like you did today for the AI startups. These will be animal health sector startups, working in a lot of the same types of AI technology and diagnostics. And so seeing how AI is leveraged in those different spaces. And then we'll be having a VIP event over at Eats and Beats. So you're happy to join us for any and all of that. Registrations are online, but if you need those, please reach out to us. We're happy to get those. I just kind of wanted to close up with a lot of what you've heard today between Department of Commerce, between the Plug and Play team. Really what we're trying to do is create that hub of innovation here in Topeka. And while that has started with our animal health and ag tech sectors, we've had that relationship going for the past 5 years, and we're doing great work in that space. We have labs that will serve kind of those biosciences, whether it's in animal health, human health, pharma, other aspects. We also have lab spaces that can work more in that advanced manufacturing, AI type spaces, robotics, in that digital space. So we're really trying to attract a variety of startups to this space, where we really see some of the most creative collaborations and where the true innovations in technology come from, or when we see those startups across industry sectors really kind of collaborate and work with each other. Having this type of space is what drives that. We've modeled this after a lot of spaces that we've toured, looked at in a variety of industries. My background's actually manufacturing. I've been doing this for about 4 years now on the economic development innovation side. And really where you see things move is when you have a facility like this. So we've fought hard to get this facility built here in Topeka. We want people to use it. We want people to see it. So as we tour the space, for those of you who are able, this space, the executive boardroom, and a couple of conference rooms in the back, those are all available for public use. So if you've got meetings, if you've got things that you want to use this space for, please let us know. We're happy to have people use this space. We want people to use this space and see what's going on here at Link. We will also be putting updates on all the screens out there as we bring companies in and the types of technologies that they're working on. So really trying to educate our community on what's going on in this space. Or if you're coming across startups that are looking for that type of space, we're happy to have those conversations. But I would encourage you to work with the Plug and Play team. Like Lindsay mentioned, we as Go Topeka have a partnership with them right now. if you are looking for a particular solution, let's talk about it. There's a lot of things we can do from deal flow type of situations to help resolve some of those solutions. Also would encourage you guys, I know I had a great conversation with Jason. We're always looking for manufacturing partners too, as some of these startups come in and are looking for ways to kind of get pilots and get their ideas or their technologies out there. Sometimes we're needing manufacturing partners to make that happen. So there's a lot of reverse connecting that can happen as well. So just highly encourage the conversations. We're happy to connect on any of those fronts. Ask us questions. We want this to be a successful venture for our community to really diversify our economic base here in Topeka, drive new businesses, drive our existing businesses, help everyone grow and succeed. So thank you for coming today, and I'm happy to give tours.